right. Hi, I'm Mikyo. I'm here from the Arize team working on the OSS solutions for observability. Today, we want to talk a little bit about our integration with the Vercel AI SDK. Today, here I have Parker, who's also been instrumental in building out the AI SDK instrumentation. And with that, we'd like to kind of do a live code through of how to get instrumentation set up with Vercel. So I'm going to share my screen here. So, want to talk a little bit about what's the first thing that you need to do to get started with instrumentation. So, Vercel has just recently launched supporting the AI SDK, now natively supports OpenTelemetry. And so, you're going to need the AI SDK 3.3, as well as some of the observability packages that we have published. And so, maybe you can walk through a little bit of some of the packages you see here, Parker.
Yeah. So you can see there on line 23 and 24, you have the Next.js, the AI SDK, um, and then as well as on lines 14 and 15, those are the Arize packages that allow you to send your Vercel AI SDK spans to Arize or Phoenix. And then as well, we need a couple of OpenTelemetry packages to make this all work. So that's the stuff in the middle there. And yeah, shouldn't leave out line 22 as well. You need the Vercel OTel package. So yeah, that's kind of a brief overview of the dependencies needed to get this all wired up.
Cool. Yeah, so once you have like Vercel OTel set up, now that means like your Vercel application can export traces. Notably, it's going to export traces that are native to Vercel, like the fetch API, as well as the routing that's happening with your next router. And so in order to turn on telemetry, you're going to first have to jump into your next configuration. As I mentioned earlier, instrumentation as well as telemetry is currently under experimental. So in your next config, you're going to want to extend the experimental block and enable instrumentation hook true. And so once you enable this Boolean flag, you're going to hook into the native instrumentation that is the Vercel SDK natively exporting traces. And so if you set up this hook, you're going to have to add one more file. So there's an instrumentation file that will automatically um, basically get picked up and will contain all the configuration that you need to set up telemetry. And this is where kind of the OpenInference instrumentation comes into play. And so, yeah, as we previously mentioned, we have the Vercel OTel, which is the package to register instrumentation. By default, this will just work out of the box for instrumentation, and you can already collect these in Phoenix or Arize as well. So the one thing that's slightly different about this configuration is line 16 through maybe 35. First, maybe let's talk about setting some um, resource attributes. So the first thing that you're going to want to do is set this resource attribute project name. Now, this is just specific to Phoenix. You don't have to do this if you don't want to, but this basically tells us that what is the name of your project. So you can say, this is my Phoenix Next app, or maybe you're deploying this to staging and production. You want to change the name according to that. You can kind of set the name here. So this is completely optional, but you can import this semantic attribute project name from the OpenInference semantic conventions and put that as the attribute here. And then the next thing that you're going to want to do is add the OpenInference simple span processor. Now, this step is not entirely necessary, but maybe I'll ask Parker to tell us a little bit about this span processor and it's what it's doing under the hood.
Yeah, so if you're familiar with OpenTelemetry, you may have seen simple span processor or batch span processor in the past. Basically, we've extended those two span processors in OpenInference. And what they do is they take Vercel native AI SDK spans and grab the relevant generative attributes on those spans and convert them into OpenInference compliant spans. So If you're familiar with OpenInference, you know we have things for tracking LLMs, re-ranking, retrieval, et cetera, embeddings. And basically, we're taking the attributes that are already on the span and appending OpenInference attributes. Uh, Something that's notable here is that our span processors take in a span filter block there. And what that basically does is allows you to specify which spans you want to export. So in this case, like Mikio said before, there's a lot of spans that get picked up by Vercel, OpenTelemetry, fetch, the next routing, etc. If you're interested in seeing all that stuff, you don't need to specify anything here. For this demonstration, we're more interested in looking at the generative spans. So we have this filter here is OpenInference span. This will allow us to only export spans that are doing things like LLM calls, retrieval, embeddings, etc. So any span that basically has an OpenInference span kind will be exported. And this is totally flexible, so you could put any conditions you want here, completely configure what you want to export to Arize or Phoenix or whatever collector you may be using.
Great. Yeah. So this is definitely just like convenience that we've added to be able to just only look at generative stuff. A few other things to know here is that you notice an API key. We're just using today, we're going to use a hosted version of Phoenix, which has like an API key to make sure that the traces are exported to your proper your instance of Phoenix. If you're using like a local instance of Phoenix or your own deployed Phoenix, you don't need this header whatsoever. We've also made it easy and convenient to just be able to configure the endpoint, but in this case, we're just over HTTP exporting our traces to the V1 traces route. Now note that, you can also enable batching and you can also export through gRPC as well. I think that overall covers the overall Next.js setup, but it's worth noting also that Next.js is doing telemetry super incrementally, and so you actually have to enable it on a per AI SDK call as well. So let's dive into that a little bit. So we're going to go to the app AI chat route, and we're going to look at one of the invocations of stream text. And you'll notice here also you have to kind of enable this experimental flag saying experimental telemetry, enable true. And here we've also added the ability to add some metadata. This is really convenient if you want to be able to like filter and slice and dice your data in the UI after it's been ingested. So you can put any custom metadata here, and that will also be tracked by Phoenix or Arize. Anything else to add here, Parker?
I don't think so. No, I think we pretty much have it covered. I think you might need to save the next config file after you enabled telemetry, but oh
Good
no, looks like you're good. So yeah, no, I think we're good to go.
Good point, good point. And I have a local environment variable that's already set up. This project obviously is using OpenAI, so we're going to need an OpenAI key. We're also going to need a Phoenix API key since we're using it with a hosted Phoenix instance. So just a key that's available through the UI of hosted Phoenix or your own Phoenix. We've kind of duplicated some configuration here, but we're going to send it over to um, the hosted Phoenix instance. So with that, let's maybe get up and running. So I'm going to run the application. You'll see now that Next.js has the instrumentation hook set up, and you can see the attributes are being initialized here for our Next.js application. So let's take a look at the UI. All right, so now we have a chat UI created using Next.js. Let's ask it some questions. So, Parker, what's a good question to ask?
Um, uh, let's think. What is the purpose of Arise Phoenix? Something like that. Let's see if GPT 3.5 is up to date here.
All right, sounds good. Cool. So now our responses is streaming in, and Next.js is kind of working as previously designed, but let's take a look at our hosted Phoenix instance. So now we have this the trace for our specific application. So what is the purpose of Arize Phoenix? We can see now it's calling OpenAI. We can see the invocation parameters like the max tokens as well as the LLM output. And then we can, use all the niceties of Phoenix, being able to filter by token count. We can also annotate this information with, some quality assurance metrics, things of that nature. So this can be a real powerful tool as you kind of move towards production and even in development, being able to kind of look into the inner workings of your application as you're running it. So I'm pretty happy with the instrumentation. Parker, anything else to add before we deploy this to production?
No, I think it looks good. I think maybe one small thing is that the OpenInference attributes get appended to the span, so you're not going to lose any of the data that Vercel is adding there. So yeah, it should be totally complete and yeah, exactly as you would expect if you were viewing it without going through the OpenInference process.
Yeah, that's a good point. There's a bunch of conventions that are coming out now around AI, notably the Gen AI conventions as well as Vercel's proprietary AI conventions. And so we try to kind of maintain those as they stream in, and you can kind of use them. We think of them as kind of complementary things as we move towards consensus on the conventions there.
Yep.
So with that, let's deploy this application. So I'm going to go to Vercel. Maybe let's ask one more joke. So I don't know. Tell me a joke. Cool. Okay, so let's go to Vercel. And now I'm going to add a new project. I have this project set up as Phoenix Vercel telemetry template, so I'm going to import that. And I'm going to deploy this. Now I need to set my environment variables. So we have that Phoenix API key. I'm gonna do this. We will obviously remove this part of the recording just so that we're not leaking information. So I'm gonna go over to my hosted Phoenix instance and get my keys here. By the way, this project that we're deploying here is available as an open source project under the Arize AI organization as the Phoenix Vercel telemetry template. It's also worth noting that OpenInference Vercel can be installed from npm pnpm at Arize AI / OpenInference dash Vercel and is maintained under a monorepo. Under GitHub here at the OpenInference project. So here you can kind of navigate into the JS directory and look at all the instrumentation we have already set up for various libraries like LangChain, LlamaIndex, and the like. Okay, let's check back in on the project. Well, cool. Now
Oh,
we get some confetti saying that it's been deployed. So let's check it out. Let's ask it another joke. So this is the great things about Next.js. We can add annotations and things like that even in the UI. But let's ask it a joke. Tell me a joke about let's see. Um,
programming.
Programming. Okay. Good answer there. Question there. So let's see. Okay, so why do programmers prefer dark mode? Because light attracts bugs. Very good. Now, if we come back into our Phoenix instance here, we see that that question has been streamed into our hosted Phoenix instance, and now we're able to evaluate, add it to data sets, annotate it, also programmatically download this information as well. So, as previously mentioned, the Vercel AI SDK and various instrumentation is now under this GitHub repository, Arize AI OpenInference. Also, if you are a fan of Phoenix, you can go to Arize AI Phoenix. Definitely give us a GitHub star if you're enjoying the open source observability. Anything last thing to add, Parker? I think I'm super excited about this integration and to kind of see where your next JS application goes.